Hi, Madison, are you there?
Yeah.
Hi, Madison. I understand you have a math problem for me, right?
Yeah.
Okay, let me go to the board.
Okay.
Now, Madison, you're a 5th grader?
Yeah.
All right, where do you go to school?
I go to school at Layton Elementary,
Okay, and what city's that?
Oswego.
Oswego. You get lots of snow up there, don't you?
Yeah.
Yeah. What's the question you have for us tonight, Madison?
In the 5th grade at Lednaput Elementary School, there are 4/5 as many students who do not wear glasses as those who do wear glasses. If there are 60 students who wear glasses, how many students in 5th grade? How many students are there in 5th grade?
Okay, let me make sure I copied this correctly as I was trying to write quickly here. All right, so in this elementary school, I misnamed the school, but that doesn't matter for what we're doing. The 4/5 of the class do not wear glasses, right?
Yeah.
Okay, but we know that 60 do wear glasses, don't we? And that's the trick part. They told us how many do, not how many don't, but we want to know how many kids there are altogether?
Yes.
Okay, now have you been taught to do this with a tape diagram?
Yeah.
Okay, let's do that. All right, so tell me what I want to do with my tape diagram.
Split it up into 5
Very good. How come? Why 5?
because the denominator is 5.
Okay, so the denominator is 5. So you're correct. We want to break that up into 5 pieces. Let me see it. 1, 2, 3, 4, 5. Very good. All right. So it's 5 pieces. But what do we know?
That we only know that there's 60 students who wear glasses.
All right, good. And if 4/5 of the kids don't wear glasses, how many? What fraction do wear glasses?
1/5.
1/5. So one of these would be 60 kids, right?
Yeah.
All right. But what we know is that 1/5 is 60. That means each one of these would also be 60, right?
Yes.
Yes. All right. So we add those, let's put those 60s in. And now we could solve this 2 different ways, right?
Yeah.
We could add all those up, but what would be easier?
Subtracting.
Well, we don't want to subtract, but we know, okay, let's look at, we've got 5 boxes here and each one have 60 students in them, right?
Yes.
Okay. Now we could add 60 times plus 60 plus 60 plus 60 plus 60 5 times, or would it be easier if we just multiplied 60 times 5?
Yes.
Okay, either way would give us the correct answer. Let's do that over here. So we have 60 times 5, right? And help me out. 5 times 0 is
0.
0, and 5 times 6 is
30.
30, okay? So the total number of students would be 300, right?
Yep.
All right, now let me make sure that I'm giving you the right answer because I think you said we had to give the total number of students, not how many students don't wear glasses, right?
Yeah.
Okay, yep, and it's real important we make sure that we're answering the question they asked because we could do this all this math correctly, and if they had asked how many kids don't wear glasses, we wouldn't have gotten the credit, would we?
No.
Oh, okay, well, you did a great job. Thanks for calling. Call again.
I said, hey, hey.
King Henry died drinking chocolate milk. This silly sentence, called a mnemonic device or a memory tool, can help you remember the order for converting to the metric system. Kilo times 1,000, hecto times 100, deca times 10, deci times 0.1, centi times 0.01, milli times 0.001.
All right, Sam, you have a little lesson for us.
Yes, I do. I think I'm going to talk a little bit about roots and real numbers. Let's go
All
over
right,
to the
good.
board. Roots and real numbers. Roots and real numbers. A number that is multiplied by itself to form a product is a square root. That's something like 2 times 2 is equal to 4. So the square root of 4 is 2. And we'll talk a little bit about why that is and give you a better understanding for that. Positive real numbers have 2 square roots. And we generally symbol for square root is that symbol there. When you see that, Basically what it means is what we're going to be doing is finding out what number inside of it is multiplied by itself to get that number. There are things called perfect squares. Perfect squares are numbers that are multiplied by themselves. For example, 2 times 2 is 4. 4 is a perfect square. 3 times 3 is 9. 9 is a perfect square. 5 squared is 25. 6 squared is 36. Square roots are pretty popular and pretty important in math, and you really want to know what they are. Normally, there is a number right here that is called the index. And a square root, that number is 2. And we never write it. So for a square root, we never write it. We just leave it blank. And everybody knows that means square root. There are things called cube roots. What that means is, what do you multiply by itself 3 times to get your answer? For example, 2 times 2 times 2 is 8. If I wanted to know the cube root of 8, I would write it this way. My index would be 3. And what I would be asking is, what number do I multiply by itself 3 times to get 8? And that answer is 2. Another example I have here is 16. This time we want to know the 4th root of 16. What do I multiply by itself 4 times to get 16? And the answer to that is 2. Why? Because 2 times 2 times 2 times 2 is 16.